Who here has heard of microfrontends? All right, got a good number. Who here is using them? Got a few people. Who here is a little bit suspicious that nobody should be using them? Anybody? All right, we've got some hands. Thanks for your honesty. Today, I'm going to walk you through Fastly's microfrontend setup, the technology we built out for this, and whether they've lived up to the hype for us. I'm Bekah. I'm a senior software engineer at Fastly, where I'm on the UX platform team. We're the team that maintains the libraries and infrastructure used daily by front-end engineers at Fastly. Fastly is an edge cloud provider, which means we take content and computing power and put those close to your users. But in 2023, we realized we weren't shipping our own front-end to users quickly enough. This wasn't an edge compute problem, but actually a core architectural issue. The one front end that we showed to our users was actually 6 different front ends under the hood, powered by 2 different frameworks. We switched between each of these front ends with full page reloads, which means you click a button in the application and everything leaves the screen, you see a white screen, and you probably wonder, did my browser just crash? Now, as you might have guessed from the title, we solved this problem with micro front ends. But before we dive into those details, I want to make sure we're all on the same page about what I mean by a micro front-end architecture. So we're going to think about some front-end architectures with the builds, deployments, and the composition of the application. For micro front-ends, we have decentralized builds, where we probably have code split into different repositories. We have independent deployments, so each micro front-end can be deployed separately. And then there's dynamic composition. So at runtime, you take those micro front ends and you swap them in and out without the user ever seeing that swapping happening. This is in contrast to a standard monolith, where you have all of your code together, it builds together, it deploys in a single deployment, and there's static composition, because you don't need to do anything at runtime. You have all of your assets ready to go at build time. But then there's this in-between state, where you get the nice things of decentralized builds and independent deployments, but the way you're doing that is by page swapping, doing full page reloads. I like to call this the conglomerate architecture. The conglomerate is a place that you often end up in as an intermediate state, but sometimes it sticks around for longer than you intended. So it's sort of a bad state you end up in for good reasons, where maybe you've grown or you're changing technology stacks and you needed a way forward quickly, but you end up living with it for longer than you had planned. How many of you have been in this situation before? Show of hands. Okay, several. So this is the same situation that Fastly was in when we started wondering, are micro front-ends the right choice? Not everything about this conglomerate setup was bad. So there were some good things going on. We had a lot of team autonomy. Teams could deploy independently, so you weren't worried about who was merging what. You could deploy just your application. And it gave us a system for incremental modernization. So again, we had both Ember and React, and we were moving toward React, but we didn't need to pick everything up and move it over quickly. We could take our time. We also had a mature design system in place. So we had styled components we could share between our applications and design tokens that we could share to make sure that everything looked like the same application, even if it didn't feel like the same application. Then there was some bad stuff going on too, right? We already talked about having a lot of full page reloads, and those coupled together with frequent redirects. So the redirects felt really painful because as a user, if you're redirecting and every time the screen goes white, again, you're thinking like, did my browser just crash trying to get around an application? We also had a really inconsistent user experience. So each of our 6 front ends was bundling its own version of the application shell. And for us, that was the nav menu and the account menus. So if I went and added a new button to the nav for application A, and I took the new version of the application shell and shipped it, the other 5 front ends might not have that new version of the nav yet. So you'd move around the app and think, wait, did I just see like a button in the nav disappear or change names or something? And you often did, because we were bundling that in for each of our front ends. So we started to think, okay, we know what the front end architectures are. What are the options we have? We were in this conglomerate state in the middle, and we knew it wasn't working for us. It wasn't a great path forward. We thought, should we go back to being a monolith? Should we put everything together? This doesn't support multiple frameworks, so it wasn't a great option up front for us because we didn't want to pick up all of our Ember code and move it to React quickly. The other thing is that a monolith deployment really reduces team autonomy. So we were going to end up stepping on each other's toes, and we wanted to keep that autonomy. Our teams really appreciate that. It fits into our engineering culture, so it's something we wanted to hold on to if we could. But with microfrontends, we got the good parts of a conglomerate, and we got rid of that bad page swapping, because we could do things dynamically. So we started to kick the tires on this and looked at 3 different options for implementing microfrontends. First, we considered module federation. At this point, module federation was version 1. So we started digging in and noticed there's a lot of complexity here. Module federation is built to scale up to a huge, huge system, or to allow you to split microfrontends into really small pieces. We knew we wanted our microfrontends to be essentially a group of pages for each team, so we didn't need that small scale, and the complexity we got for the scale wasn't worth the trade-off. And then because this was module federation v1, there was a dependency on Webpack at the time, and we didn't want to introduce that into our stack. Next, we took a look at single SPA to see if that could be a solution. The 2 things that stopped us here were it has Ember support, but it didn't actually fit our specific setup of Ember, so it wasn't going to work for our needs. And we couldn't write the navigation in React. They provide their own third-party tooling that you're supposed to use for building your navigation. And if we were going to standardize on React, we wanted to standardize and move everything over. So that wasn't very appealing. We started thinking, could we build our own thing here? There's some new browser tech we could take advantage of. And hey, we know a guy for edge computing. It's not going to be hard to pick a vendor. We can handle that. So Fastly's microfrontends were born. We're going to dig in now and take a look at what this looks like for a request and how we serve assets with our microfrontends. So first up, we're going to start really high level. You make a request to manage.fastly.com, and you'll get back an index.html file. Pretty standard stuff, right? Let's look at some of the browser tech that's going into that. I'm going to say new with a caveat here that it's not new anymore, but it was at the time we were looking into it. So first up is native ES modules. This allows you to use ES modules in the browser and just import an ES module and run what's in it. Second is import maps. So these allow you to, for a given import, tell the browser how to go and find assets for that import. And thirdly, dynamic imports. So you don't have to have every import defined at build time. You can have dynamic imports that are resolved at runtime. So we're going to go back and think, OK, we've got this index.html file, and this is coming back from the internet, we're saying here. What does that actually mean? Well, when your request gets resolved, it's going to land on Fastly. So the green icon here is an edge compute service that we use to generate the index.html file at runtime. So we aren't building an index.html file and shipping it. We're actually creating it every time it gets requested. This gives us the advantage that when we read the versions, if you go down and see our Edge config store here, you'll always get the newest versions of our microfrontends. So anytime someone updates, we know we can get those to our users quickly. And we instruct the browser not to cache the index.html file so that you're always getting the latest versions. Now you might be wondering, like, why go to the fuss of this? You could do this all at build time, right? And we could. The nice part about doing it at the edge is we allow teams to deploy fully independently. So a team can update the version, and that's all they have to do. Once they've uploaded their assets, they update the version in the config store, and their code is going out to users. They don't have to step on some other team's toes trying to build a new index.html file where everyone needs to get in there and update their versions, and you end up with merge conflicts between them. You just update your own entry in the config store, and you're good to go. So how does the browser actually know how to use these different versions? We use an import map. So this is what our import map looks like for all of our microfrontends. On the left-hand side, the key is the common name we use for our microfrontends, and the right-hand side is the import path. Let's take a closer look at these import paths and see how they break down in our system. So first up, we have the route identifier. This is what we use in the compute service to say, okay, this request is looking for package assets, send it to our package asset handling. Next, we have the package identifier. Because we've stripped the key value and we're only getting the value at this point, we still need a way to say, hey, you're looking for homepage assets right now. So the system reads this and understands that's what it needs to look up. Next is the version identifier. This is normally a 40-character Git hash. So you can use whatever you want. You just have to make your system understand it. But we've opted to use Git hashes because we already understand those. We can keep track of them. And it's really easy to understand what version is in production and how to go get that code if you need to run it locally for some reason. Then lastly, we have the file path. So here we're getting an app.js file. That is how we're getting our ES module that holds onto our micro front end. So when this request gets sent into the system, the compute service is going to read that package identifier and understand, okay, you're looking for package assets for homepage. And then we have configuration that tells us how to look up those assets. So it will go and look up homepage's assets. At the version we're looking for, return them back. We take this opportunity to cache that, and then we send it to the browser. So you're looking at an uncached request right now. But we actually cache these with a very, very long TTL because we know if homepage gets a new application version, that will update in the config store, and our users will get it quickly, and we'll just let these assets age out of our cache. So we don't deal with any like cache purging because we don't need to, and it would be kind of complex to add cache purging. We'd have to key things to make sure we only purged the assets for the specific micro front end that changed. Instead, we just let things age out, and we use cache busting to make sure you get the newest assets. Now you'll notice here, everything is using that same path that's in the request. And you might wonder, like, doesn't this take away some of the autonomy you've talked about? Do teams have to store all their assets in the same place? And the answer is no. We use some configuration at the edge, again, to understand how we take any asset path and turn it into assets for a given micro front end. So you can put your assets in whatever cloud provider you want to, you can put them at whatever path you want to, and as long as you've told this compute service how to look those assets up, you're good to go. It needs to be able to take that information and turn it into assets. All right, so how does this actually get rendered? There's one more piece of the system you need to know to understand how this is getting rendered into the browser. That's our orchestrator application. So we have a single application that the index.html file is always importing and starting up. When it does that, it gets all of the context of our orchestrator. So that's the orange code block up top where we're importing and starting it. Then let's take a look at our yellow code block down here. The orchestrator has a couple of important jobs. Firstly, it's rendering our unified nav component. And this is regular React code. There's nothing special about this. So it's rendering nav onto the screen, and then it renders the child micro front end into it. If we dug into the code for that child micro front end, we'd see a few different things. So first of all, the orchestrator has a manifest that goes from whatever route you're in the application to the micro front end that's supposed to serve it. So it understands, okay, for this route, you want homepage. Great, I can do that. Then it's going to import homepage. The browser will use the import map to understand that import homepage means go get those assets for homepage and bring them back. And then the orchestrator will boot the child micro front end and display it. So this is what it all looks like when it comes together. It looks like one application, but there are a few different micro front ends on the screen right now. So first up, in the white highlight here, you can see our unified nav. We have navigation on the left, our search on the top, our account menus on the top, and this we're only rendering once. So you're never seeing the buttons on your nav change as you hop around anymore because we have a single source of truth for where the nav lives. Next, we are highlighting the child micro front end. So this is our homepage micro front end, and you don't know as a user whether you're looking at an Ember application or a React application. And you don't need to know, you shouldn't know that. It's all gonna look and feel like a single application at this point. This has allowed us to really organically move between frameworks. So like I said, when we considered a monolith, we thought we would have to pick up everything from Ember and chuck it into React as quickly as we could. We haven't had to do that, so instead we're taking our time to move from Ember to React and doing things like design refreshes and tech debt cleanup and implementing user-requested features and really letting this grow organically over time. Now, I'm gonna highlight one little bonus thing. If you'll look to the top right, you can see the highlight is on the notification bell here. This is what we jokingly refer to as our nano front end. So this is actually its own very small micro front end, and we split it out this way because there's more to the micro front end. We have a whole notifications page that you can view, and we wanted the data to be shared between the notifications bell and the larger micro front end it's a part of. We don't have a great way to signal data between micro front ends at this point, so instead we render a tiny version of the micro front end into the nav and let that communicate with the larger version of the micro front end. So this is cool because we set out for page level micro front ends, right? But we've been able to adapt the system a bit to smaller micro front ends as needed. We try to not go too deep on this, but it's a nice pattern when we have a good reason for it. So that's how Fastly's micro front ends work. Now, if you are really interested in this and you wanted to leave today and build your own system that looked like this, there are a few more things you would need to know. And we don't have time to deep dive on all of them for the sake of a 30-minute talk. So I'm gonna do a lightning round. And in the spirit of putt-putt from yesterday, there are prizes. Okay, lightning round. Question 1. How will users feel if you break the back button? Shout it out. Yeah, they're not gonna be happy about it. Okay, let's see how this goes. This is just gonna be a grab bag. I should have picked something heavier, I think. Or you can all move to the front, whatever. Okay, so you need to manage browser history. The browser APIs don't have a way to do this where you can signal between micro front ends. So you'll need to find your own strategy for managing browser history. What we've done is we've built a library that we externalized, so all of our front ends share the same data, and that library is what you signal when you change your history. So you say, hey, I'm getting a new page, it pops something onto the history stack, and then the next micro front end that loads in, it will pass all that history over to it. So when you hit the back button as a user, you're still gonna go back to where you expect. We maintain your browser history. Okay, second thing. When you build an application, what's your standard entry point gonna be? An index.html file. I don't know who said that, but if you wanna come get your prize. Okay. So an index.html file. So you need to think about how you're gonna bundle applications as ES modules, because that's what we're loading into the browser. Like Sarah Drassner said yesterday, you can actually affect the DOM using JavaScript, right? So we have all of these ES module files and their JavaScript files, but they put all their content into the DOM as well. So you need to think about how you're gonna bundle applications to have just one index.html file, and that's the one you're generating at the edge. All right, third thing, is putting assets into the browser enough to load them and show them to the user? If the browser requests assets and gets them, what's it gonna do? Nothing, right? I see some like shrugs going. Yeah, nothing. You need a way to actually render those in. So you'll need an entry point, and then you'll need to make sure your application also exits cleanly. We are using mount and unmount functions. You can pick whatever name you want here. It just needs to be standardized. So every micro front end has to have this, and the orchestrator will call in and say, great, I'm gonna mount up a function, and then when a micro front end leaves, it will call its unmount function on the way out and clean up. All right, last one. We have micro front ends, things are split up. Do we want all of our CSS to be together? No, right. So you'll need a way to load and unload the CSS for each micro front end. And unloading here is just as important as loading, because these micro front ends don't know anything about each other at build time. So they might actually end up with CSS collisions if you're not careful. So you want to have a way where you can load in the CSS when something mounts, and you can kick it all out when it unmounts. We're using a Vite plugin to do this for all of our React apps. So again, this is something where you can come up with a standardized way to do it and then provide tooling to your micro front ends. They don't each have to reinvent the wheel on this. So if you were to leave here today and implement a micro front end system that looked like this, these are 4 things you would need to know about. While we're here, I'm going to put in a plug for one thing I think you should build in because it's great for developer experience. And that is version overrides. So because we build out the index.html file at the edge, we can actually pass a special parameter that says, hey, I want this specific version of this specific micro front end. The edge compute service will read that in, put it in the import map, and send it back to you. So when you get that back from the browser, it looks exactly like a deployed asset. But we've just ignored whatever version is actually deployed, and we're doing an override. So we see here in the top screenshot, we then put these links on every single one of our PRs. So you get a preview link with every PR, and that will put the special query param in place that says, hey, give me this version of the application, and you can test with it. You can hand it to a designer and say, hey, I noticed these designs feel kind of funny. Like, do you want to play with this for a minute and see how it feels? And you can get early feedback on things while you're still in the PR phase. So this is really helpful. And because it looks just like your deployed assets, it's very safe. It's not like you are doing something super weird. Like, it's coming back and looking exactly like your deployed assets would. So this is really handy. It makes our development cycles much faster, and I recommend throwing this in if you get the chance. So we started out thinking about what was going well and what wasn't going so well. We've taken all of the bad things using this system. We've actually moved them over to good things. So our page changes are all seamless. Our redirects are fast now. So we have just as many of them, but they're not painful for our users anymore because they don't feel the whole application disappearing. And we've created a consistent user experience. You're no longer in this state where moving around the application might leave you with buttons that weren't there before. Now we can stop thinking about what's bad and right in front of us and think about the next steps for the system. So the first thing we're thinking about is how we share data that's expensive to fetch. We've started on this work with auth data. So right now, every micro front end makes an auth call as it boots up, and that's a blocking call for rendering before it can actually show the user anything. This can make it feel a little bit slow to get micro front ends going. And that's not because the assets aren't already in the browser and ready to go. It's actually because we're making API requests. So we've built an externalized auth library that all of our micro front ends can share. And that means that when they switch to a new micro front end, it just grabs the auth state from whatever got it last. And we keep refreshing that in the background, but you no longer have to make a request and wait on it to boot your app. So it feels instant. When you switch between our applications that are using this system, it's just immediate. The other thing we're thinking about here is sharing dependencies. So we started with 6 micro front ends. I think we're up to maybe 10 or 11 at this point. And all of our React ones are shipping their own version of React. They're not sharing dependencies at all. We could bring in a really big hammer for this, like module federation, where it's built to handle exactly this problem. But we don't think that's the right size for our scaling needs. It feels like a bigger tool than what we want to bring in. So we're still thinking about this. We haven't solved it yet, but it's not affecting our users. You know, we still have that instant reload between our micro front ends. And so until this becomes a higher risk, we're going to take our time and make sure we pick a solution that fits our own scaling needs. OK, here we are, last slide. Now, based on this case study, does anyone feel better about use cases for micro front ends? OK, all right, we got some hands. You know, I feel better having seen this system and helped build it. So the key is to know your scaling needs. You don't want to bring in something that's super heavyweight if your scaling needs don't match the weight of that tool. Sometimes a lightweight solution is all you need to stop shipping your org chart out to your users. I hope that after today, you'll have a better sense for when micro frontends really will live up to the hype. Thank you.